Sir, I have a doubt. It's right now.
Yes. Yes, tell.
Sir, this integration is anti-derivation, right?
Yeah, that is also one way of thinking. It's called antiderivative. Yeah, antiderivation.
Sir, then if we take integration of sec square x, then we will get 10x, right?
Right, right.
Then sir, here what is integrand and integral? Integrator.
Yeah, integrator is a dx. See, when you write anything like some function dx, what does it mean? Is let's say you think this way, like if you know the history of India, then you must have heard about who was the national integrator of India. So you say it was Sardar Vallabhbhai Patel. He was the national integrator of India. Do you know this fact?
Yes, sir.
Okay. So now imagine if Sardar Vallabhbhai Patel was an integrator, then he was integrated from only one country called India. He was not the integrator of Pakistan or Bangladesh or Bhutan. Okay. So now how we'll come to know that who is integrator of what? For example, if I write here f of y and if I write here dx, the problem is that he is the integrator of x, which is the country India, but the function is y. Now, if y is independent of x, let's say if indirectly also y does not depend on x, although I have written it's a f of y, but if I say that y does not depends on x, so it's like a totally independent function. So since it is totally independent function and nothing to do with the x, even remotely, then integrator will not act on this function and it can be taken out of the sign of integration. So it will be just as good as 1 dx. But if y depends on x, then we cannot do the same. Of course, it means indirectly it is a function of x, like something called the
So
composite
that one
function.
is multiplied with dx, no?
Yeah, dx. Now dx will integrate to 1. So now this is a rectangle of fixed height. The height of the rectangle is 1, and you're integrating from, let's say, 0 to x, or like whatever. Like, so the height is fixed. This is called height. This is the height part. This is the height. Now, if height is 1, let's say this is 1, and you integrate from 0 to x, let's say 0 to x, then what is this area?
X.
Exactly. So when you learn later on, when I will teach you derivative, this will become 1, and this will become x if I integrate from 0 to x. Okay. So the meaning of integration is this only. Like you integrate and you eventually get the area. But the problem is when you see a function, let's say you just said someone said sec square x dx, this is not having fixed height. The height is changing. Height is changing as per this formula. So the area will have a variation of height as per this formula, sec square. Now this formula is something difficult to plot. So imagine we have a area which is following this particular function, this function. So the height of the graph is changing, and you're multiplying by dx, and then if you find those area, let's say some random area is coming here, and if I find this area, then I will see that this area is as good as 10x. Okay. Plus something also. I mean, of course, it will not end here only. So something more to it is there. I will discuss in a while.
Sir, then
Okay.
f of x equals to y is nothing but uh, the function of 10x. Right?
Correct, correct. So you know, if you add all area, so it will follow the area will follow the pattern of 10x. Like the area value will be same as 10x plus something. Okay. So we'll see just in a while. At the end, whatever you write is the height into width. That's it. Or you can say length into width. So length into width, the length will vary over the space over the coordinates of x value, and the variation will be decided by the function which you write there. So for example, someone is writing x dx. Let's say without solving, I mean we can solve easily. And let's say you want to integrate from 0 to 1. Let's say this is just a question. Imagine. Now what you can think is that this is the function. This is the function. Dy dx upon dx. No, nothing like that. This is something I don't know. Dy dx by dx. Okay, you are multiplying the. Okay.
Yes, sir. Dy by dx into dx.
Okay, so what is the benefit of that? Okay, I'll see that. So now the idea is x dx is not integration, it's just area. Now, if you know the graph of x, you can plot. If you know the graph of x, can you plot the graph of x? If you remember the graph of x, it will be like this. Passing through origin. Okay, this is the graph of x. And let's say you want to integrate from 0 to 1. So you are looking for area between 0 and 1. So you are only interested in this area. And because it's a y equals to x graph, this graph is called y equals to x. So when x is 1, comma 0, the y of this point will be also 0, comma 1. Now, current guys, tell me what is this area? How much is this area? This area is how much?
Sir, 1 by 2.
Correct. So now, even if you know the integration formula and all, and if you do this, you will get the answer 1 by 2. Now, what happens where, like in cases which are difficult to plot or maybe difficult to visualize, we stick to only formula. Let's say, for example, I say, what is the meaning of sin x dx between 0 to pi by 2? Let's say
Minus
pi.
cos x.
Okay, now that what let me tell you the idea. The idea is if you plot the graph of sin x function between 0 and pi, it will look like this. Because the part I'm not considering further. So this is the graph of sin x, and this height is actually equals to 1, maximum height is 1. And now I'm looking for this area. So now this area turns out to be exactly 1. So not 1, maybe 1 or 2, 1, 2. This will turns out to be 2 actually. This turns out to be 2. How it is 2? So look at this. If you know the integration, later on we'll come to know the integration. This will become minus cos x. And we integrate from 0 to pi. So we put the value of minus cos pi. This is the way of writing. Plus cos 0 and it will give you 2. Anyway, we'll see that how to do this. But the idea is every function gives you area, and the integration formula is derived. It is like you break the area into small pieces. What you got is called the actual function. Okay. So if I differentiate this, what I get is the actual function. This is the actual function, and these are the infinite points of the graph. These are the points. So now the points of the graph, if you differentiate, you can get those points actually. Okay. Okay. So no, don't worry. I haven't started the integration. This is the like basic idea. Eventually, all integration refers to area only. Sometimes you are able to see the area. Sometimes you're not able to see the area. Sometimes if you know the graph of function, you can plot and you can see the area. If you do not know the graph of function, then you can do it just mathematically without even looking at how area looks like. And of course, you have the GeoGebra. You can plot any function and you can see how it looks like. Okay.
So,
in
what is the triangle one?
Pardon, which one?
So the triangle.
The triangle, see,
Ah,
yeah, this is the equation y equals to, this is the equation, this is height, this is called height. So y is x here, y equals to x, which you plot, you will get this line. This is the graph of y equals to x passing through origin. And I want to integrate, this is my integrator, I want to integrate x from 0 to 1. It means you want to find the area from 0 to 1. This is what we are looking for. So this is the area. And if you find this
yeah.
area, you will get half. You get half. And that is the meaning of integration. The integration will give you half.
So run that semicircle one.
Yeah, no, this is not semicircle. This is graph of sin x.
That one.
Yeah, if you plot a graph of sin x, it will be like this. So I have just plotted the only part which is from 0 to pi. And also you need to remember that the area of each quarter, if I divide it like quadrants, so each quadrant area is 1 actually. You have to remember this fact, because that will help you in solving the question faster. So each quarter will be like 1 unit. So what is the benefit of this? If I plot a graph like this, then how many quarters you can see? We have 4 quarters. And you can see the 2 quarter is above and 2 quarter is below. So all the below quarter will be negative area and above will be positive area. So the total area is how much?
0.
Exactly. So if I say ask the question, that's what is the integration of sin x dx from 0 to 2 pi? Because this is 0, this is 2.
0.
The answer must be 0. Even without integration, we can say this. That's easy part. So similarly, if I ask you that,
That one.
if I ask you this question, this is pi by 2, and this is 2 pi, this is pi, this is sin x graph. So what is the area of sin x dx from pi by 2 to 3 pi, pi by 2 to pi, 2 pi? What is this area? You can see that below is -2 and above is +1. So net is -1. Can you see this? The area wise, each quarter is 1. So below is -1, above is +1. So we have 2 quarter below, 1 quarter above. So -2 and +1. And you can remember this is -1. Is this clear? Hello, hello, hello.
Yes, sir.
So the idea is, it is at the end of the day,
Yes.
although we will have a formula, we have a set of formulas which you need to also remember. But the idea is at the end of the day, it's area. So it's good to have the visuals in mind. Let's say for the regular graph, the graph that we will face in the physics, these graphs are very simple. These are like sin x, cos x graph, y equals to x graph, linear graph, quadratic graph. And the moment you develop this graphical thinking, you can always convert a question of integration into area question. And if you can plot the area somehow, and if the area is calculatable using geometry, you can get the answer easily. Else, you have to do the more, you can say more of integration and differentiation techniques. Okay, so we'll see that. Don't worry. So let's start the formal meaning of integration. So what we learn, just like in, if you remember the dy by dx, I said dy by dx represents the slope of tangent drawn on the curve. So that was a geometrical meaning, and then later on we learned something called operator meaning. Similarly, integration is area, which is good, but we also learn integration as the inverse process of differentiation. So now this is like an operator. So we'll say integration as a inverse or reverse process. Inverse process is good. Inverse process of differentiation. So integration as the inverse process of differentiation. All right. So now, what is the meaning of when you do integration? The first thing that we look for is called the integrator and the integral. I mean, sorry, integrand. And what we look for is that is the variable matching or not? Okay, if it is not matching, and if it is not dependent on the integrator's variable, it means it's a different world. It's a different country. So first we see that is the integrator and the country of his interest is matching with the function given. So if the function is not matching, it means he will not integrate. Okay. So first of all, we need to understand that we write some function here. This is called function, and we write integrate. So now you can see this is matching. What if it is not matching? Let's say if we have something u and dx, then we need to check something. What we need to check? We need to check, is u function of x? Is u function of x? If the answer is yes, then it is eventually a function, okay, of x. So it can be integrated just like the chain rule. Okay. So maybe it looks like f of u dx, but deep inside the u is a function of x. Let's say gx. So eventually it's a function. Now for this integration to take place, what we must have, this variable should be here. Okay. So what we do is to make the variable matching the integrator, we assume something. So what we assume? So let gx, because it's not matching. Look at this. Here we have u, here we have x. So what I want is the u should match the x. So what we do, what is the trick? So because u is gx, so what is du by dx? Can you guys tell me what is du by dx? G dash x. This is how we write. If
Yes,
we
sir.
differentiate, we can write like this. So du by dx is g dash x. Okay, that's fine. So what you can realize is that I can write dx as du by g dash
D
x.
dash X. Yes, sir.
Yeah. So now the moment you do this, you can realize something very interesting. This is called the method of substitution, and you're learning very fast, very quickly. So this is f of u. So I have a choice. What I did was I replaced the integrator with my variable. So now I have du by g dash x. So this is what we do. Normally, this is what we do in solving questions. So we always try to match the variable with integrator. So there are two ways. Either you replace u in terms of x, either you do this, or you change the integrator totally. Like I'll keep my variable, but I will change the integrator. So there are two steps in integration. One is called change of variable or variable to suit integrator's variable, or change the integrator in terms of variable of function. Now these are the two crucial points that you can imagine, you can think, and the more you think, the more you will get. That's actually tremendous concept. So we always have a choice. Either I will change the integrator to suit my variable, or I will change my variable to suit the integrator. But unless this is not happening, integration will not proceed. So that is what we need to understand. The integration cannot proceed unless not suit the variable.
So,
Okay. Yes, you want to say?
Sir,
so how is that gx du by dx equal to g dash x?
No, this is how we write it. This is the symbolic notation. Like when you differentiate something, so if fx is a function, then f dash x is called differentiation of fx. That's it. It's just a notation of differentiation. So you can think that dy dx will give you this symbol. Just it's a way of writing. So how do you differentiate, distinguish between fx and f dash x? So f dash x is the differentiation of fx. That's a way of saying it. You haven't done anything. You have just written the symbol. So when u is gx, then du by dx is called g dash x. Now you have done nothing. You have just written the way it is called. And this I think we have discussed. I mean, uh, we have done a lot of question in which I have used this symbol, the dash symbol for differentiation, right? So now dx we can write like this. Okay. So just wait for some time. So in integration, what I said that if we have x and if we have dx, it's the perfectly fine integration. So we write integration as I equals to this. Okay. Now the two integration. If we are at two
Can you
integration,
show the previous slide?
Sir, which one is the integrator and which one is the variable?
this is integrator and this is variable. Like
Sir,
the function, like this is a variable. Variable is here. So we have two variables. We have a change of I can write a functions variable to suit integrators variable, or other is change of integrator in terms of variable of function. Okay. So I should have mentioned the functions variable. So once again, just look at this. So confused. Okay. So what I'm saying is, let's say I write
sir,
f
please, will you
of
show the
u.
last slide?
Okay, once we'll do the problem, we will understand better. Just like it's a very much theoretical, it's difficult to actually
Yeah,
understand.
sir, understood. Sit down.
Okay. Now the idea is, imagine I give you a new integration like fu dx. Now, if I ask you, can you integrate? The answer is no. You cannot integrate the way it's written because we have a difference between the variable of function, which is u, and this is integrator. This is your integrator. Now, integrator is like the warning sign. It's like a sign. It says that what you can do and what you can't do. So it says that I can integrate if the function depends on x only. So if the function depends on some new variable, I cannot integrate. So to integrate, I need to match the variable of either with other. Like either you match u with x or dx, like you can keep dx as such and change u into x. So let u depends on some function g of x, which is hidden. It's not known to uh, the integrator. So let's say the integrator does not know that u depends on x. Okay. It's like dx is asking that do you have the valid passport or valid ID? Okay, then I will integrate you to my country called India. So I will look for your passport or something, and then if I find okay you belong to my country, I'll let you enter it. Maybe you're coming from abroad, and okay, we have the immigration check. So what we see there is that you show your passport, and that is like a proof that where you're coming from. Let's say a country is deciding only to let their own citizens to enter, not the other citizens. So here the u is like a function of some random thing. The x will get suspicious. Okay, what is happening here? Why u is coming to me? Because I am the integrator for my country. The dx is called I am the integrator of my country, and this is u. So now you will show the passport. So you will show I am gx, sir. I am gx. So u has proved that it is a function of x. It means integration can take place because at the end of the day, it's same country. But to formalize the process of integration, you need to write this function as f of g of x. Now the x can see directly, oh, it's a, eventually it's the same country. Okay, I will do the integration. Now this will approve the process of integration. Understood? The other way of doing this, now the citizen knows that he belongs to the same country. Okay, and let's say the citizen will not reveal the identity, but there is someone who can identify him better that he belongs to India. Let's say if you, with your dressing and with your accent, and then I mean maybe the face structure and all, we can guess which country you belong to. Okay, so if you are from the northern part of India, okay, you can be identified easily, or the southern part of India, or the western and eastern. So we can identify with voice, with language, with culture. I mean, like something, some kind of proof is there. So what we do is we will not disturb the you. Rather, I will introduce a more intelligent person who understands you better, because at the end of the day, they belong to same country. So now I have changed the identifier. I have changed the identifier to du. I want to bring du here, because I know that du can easily identify you, or you can say it will integrate you. Now the problem is how to bring you into the picture, because it is actually not there. What we have is dx here. So to bring du, I need du terms. I will differentiate here du by dx. And how we write? Okay, how you write this? Okay, if you're confused here, then this is like d by dx of gx. Now I don't know what is gx, so I cannot differentiate. So what I will do is to mark that this has been differentiated, to show the mark to the world that okay, I have been differentiated, I will put a tag. Okay, you are not differentiated. So this is the just way of writing. Like this is the meaning of this is meaningless. Like unless you will not give me gx value, I cannot differentiate exactly. So when you are not able to differentiate exactly, but because the differentiation process has taken place, so you put a tag like this. This is like a tag. Understood? G dash x. So I have the gx has been differentiated. That's the meaning. And now what we do is we rearrange. In the we bring the dx into the numerator, so we write this as g dash x dx. Now that's interesting. Now g dash x dx. So basically, I wanted to replace dx only. So I have nothing to do with the g dash x. I mean, whether g dash x is there or not. So my idea was to just change the integrator, which understands me better. So now I have got the dx, and now what I can write is dx can be replaced by a new integrator, but with some coefficient which I have to write like this. And now I will substitute here. And now this is like a valid integration. Now you can integrate. That is ideas. Now eventually we learn that a g dash x can also be replaced in terms of some sort of u only. Okay, so it's some function of u. So I can say that because all are dependent variables. So you will also realize that this g dash x can be maybe some a new function of u. That's very weird. Okay, but anyway, so this is difficult to understand from here. So I think unless I will not give you question, that's very difficult. Okay, so just wait for some time, and let's see the some formal thing about integration. So now what we are going to learn is called integration as a reverse or inverse process of differentiation. So the output of a differentiation, and you can say the output of integration, there must be some relation. Okay, there must be some relation. So if you look at the input of differentiation, it turns out to be it is nothing but the integration of the output. Okay, so it's like this. Let's say we have some function fx, and we have a device which is like which differentiates, and what you spit out is the f dash x. Okay, this is like a tag. You have put a tag that okay, this guy has been differentiated. Now let's say if I want to bring back the same thing fx. So I will make the process reverse. So what I'll do, I'll put an integrator some, and now this is the box in which you have to put the function which is coming f dash x. If you put here in this box, this will process it if it is valid only. So now the problem is the processing will take place only when the validity is approved. Okay, so now this will okay, it's a function of x, it's perfectly valid, and it will process and it will again spit out f of x. But there is some sort of in the reverse process something gets okay, added here. So we'll add something here. Now to understand that the function fx is coming and this is like a byproduct. So after every integration, you will get the function which you're looking for, but you will get some additional byproduct. This additional byproduct is called constant of integration, and I will discuss about this more in detail. Constant of integration, and I will tell you why this the byproduct comes, okay, and why the byproduct is written as plus c. Now this is the cycle of integration and differentiation. That's why we say it's an inverse process. So here, this is like a mixture grinder. You put the variable here. This is what you get, and then you put this into this function. Function is like a whatever you write before dx is called function. Okay, and dx is just like a representative of what it can do, what it cannot do. So what sort of variable or variables are eligible for integration? This is the idea actually. So when you put back this f dash x, it will give you back the fx, but with some extra c. Okay, and we'll have to understand what is this extra c. Okay, and this is the process called integration as the inverse process of differentiation. So if I want to know the integration of some function, then I need to understand when it came as the output of some function. So look at this example, like something very simple. Now, what is the d by dx of x power n?
nx is n minus
Nx n minus one. Very good. Okay, so now it means this is the differentiation of this value. So if I integrate all such value, what I'm supposed to get?
x is to n plus c.
Exactly. So if I say that what is the integration of this? If
X
I put
raised to
this
n plus
entire
c.
function, correct, it is x power n plus c. Now to make it more formalized, it will follow the same rules as differentiation. If this n is a constant, so we can take it out. So I can write x power n minus 1 into dx will be x power n upon n, and plus c will remain plus, because constant upon something is constant only. C is some constant and some unknown constant. But this formula does not look good. So to make it look good, I will go for something like this. What is the d by dx of x power n plus 1? No, this is pretty easy. The power I have
X n plus 1 the whole x raised to n.
correct. That's the right answer. So do the reverse process. What is the integration of this?
X raised to n plus 1 plus c.
Correct. So now if I bring this outside, because that's perfectly okay to bring it outside because that's constant. Now it turns out to be a very nice formula. You make us a C there, it doesn't matter. The C is some constant, that's it. So now this turns out to be an, pardon?
So why do we divide the constant which we take out?
No, this, if you take this side and if you take on the other side, it will divide, na?
Oh,
Understood?
Sir, can you explain from the third line, no, second line again?
From here.
Sir,
Yeah.
the audio wasn't clear. That
Okay. So now this is you what you need to realize is that what is the differentiation of a given function. Let's say you differentiate x power n. What do you get? You get this. So this is the output of differentiation of this function called x raised to n, right? So now in the reverse process, if you integrate this, what you are supposed to get? The process is a reverse process, inverse process.
that X is
Yes, yes, tell me.
Sir, are you asking the derivation?
I
Sorry,
have just
integration.
one question. Sir, if we take
No, no,
that an outside
someone was asking me the doubt, I think. Who was asking doubt? The audio problem? Who, I mean,
sir, me.
okay, okay, sir. Okay, sir.
Sir,
So,
so X raised to n by derivative.
yes. So, you see, if the differentiation is giving you this answer, the integration will give you the same thing, back to the same. So, what the differentiation gives, if you integrate that thing, you will get back the what? The function itself. Okay. Okay, anyway. So this is the first formula. What is the first formula? The integration of x n first with respect to dx. This is always equals to increase the power and divided by the new power. Now, why I'm putting c? That was the question that I didn't answer initially. So why c? That's very easy. Imagine that if I say what is the d by dx of x plus 2?
one,
Correct. What is the d by dx of x plus 3?
one,
What is the d by dx of x plus 21?
one,
So integration of 1 should give x plus 2 or x plus 3 or x plus 22. Which one is correct? The idea is all are correct. So the 2, 3 and 20, 21 are some random number which is also getting added. So to take care of such things which we lost during the differentiation, we add constant. Now this will take care of anything which you added here.
So C is a
And
constant of
yeah,
integration.
yeah, constant of integration. It means this is called indefinite integration, what we are learning right now. And when we do the indefinite integration, like indefinite means what? We are not sure like which part of the area is being asked in the question. Like we are not sure that from where to where I have to integrate, because they haven't given the beginning or the end. So I'm indefinite about my answer. So when I'm doing the indefinite integration without knowing that where to begin the area calculation and where to end the area calculation, in such case we just add c to take care of something unusual which may occur. So the c will take care of all those constants which might have been present in the differentiation, and because we know that when you differentiate something which is constant, it turns out to be 0. So differentiation always removes the constant part, but when we do the integration, which is the inverse process, so we are unsure about what was that constant in the beginning. Like I have no idea what was the constant in the beginning, and therefore we just put a c. Hello, hello. Who is singing? Did you understand what I said? Hello, hello, hello. Hello, hello. 1, 2, 3.
Yes.
Sir, I have one doubt.
Yeah, too.
So we do this integration in two steps. First, we integrate the whole sum. Then we take out the constant and then divide it by it. No?
Pardon once again.
So first we integrate a whole that n plus 1 then x raised to n dx,
Mhm.
and then on the second time we take that n plus 1 as constant and then divide it by
No, no, no.
like
I think you got it wrong. See, to explain why this formula came, what I said is imagine you have x power n plus 1 as a variable. Now, if I differentiate this dy by dx, what I'll get here?
n plus 1 x raised to
N plus 1 x raised to
n.
correct. Now, the idea is the identifying the inverse process. So I can say d by dx of x power n plus 1 is giving me this answer. Okay, that's good. So now, because this is a constant number, so I can bring it here. So I can keep on writing like 1 upon n plus 1 d by dx of x power n plus 1 is x power n. And then I can add d by dx, I can put it into the entire formula n plus 1 x power n plus 1. So it looks like the differentiation of this entire new thing gives us this value. So if the differentiation of this is giving you this answer, then the integration must give you back the same answer. Okay. So can I say that integration of this function must give this value plus the constant of integration, which I'm not sure what was the constant in the beginning.
Yes, sir.
Is still not understood, right?
Sir, understood.
Okay. So now this is called the power formula or the power rule of differentiation. Sorry, integration. So this is the power formula of integration. Power formula. And what you can realize that in integration, the power is increasing by 1 and we divide by the increased power. So if I ask you what is the 1 dx, so if nothing is written in equal 1, so we also write this as just dx. So it's very confusing when I write only, see, if I write only dx, then you may think that, so where is the height? So if nothing is there, you can imagine 1 as the height, because 1 into anything is that thing, right? So what is 1 dx?
X.
Correct. So the answer is x plus c. Okay. So integration of only dx is dx plus c. It will add all x, it will make it a big X. Okay, all right. So we have this, and if I write x dx, what you can write? Now we have x, which is having power 1. So what you can write here? X power 1 plus 1 by 1 plus 1,
Yes.
which is x square by 2 plus c. See, you have to increase the power and divide by the new power. That's it. It's not difficult. So what is x square dx?
X cubed by 3 plus c.
Very good. Yeah, right. It's 3, 20, 21, 1 are the constant of integration. But since I took some values, but it could be any value of constant. So that's why I put just c, because I don't know c. Now, how to know about the exact C? So that is only possible when some initial conditions are given in the question. So that is called differential equation, solving the differential equation, or something called the parameter of integration. Okay, so that will be come in the later part of this integration. So anyway, now what you are getting is answer is x cube by 3 plus c. Now there is something very interesting. What will happen if
So
you
the
have,
power formula which you gave just right now, which you are giving, is the first formula you gave for the
yeah, this is the first
operator.
formula. Yes, this is the first formula for the operator x by n. Now imagine if the power is -1, can we write something here? Can we apply the power formula here?
Oh, yes. So
Then if I apply power formula, what will get?
X raised to 0 upon
So you get 1 by 0, which is undefined.
undefined.
sir, please will you explain power formula again?
This is the any function of x power n. The answer is x power n plus 1 by n plus 1. That's it. Increase the power by 1 and divide by the new power. That's it. Understood? This formula, just look at the formula. It's not big deal. I mean, you can just remember the formula and apply it. The thing is, you need to learn to apply it. Okay, so application
So
is
we
important.
have to add C in extra, right?
Yeah, C is the extra. You have to just add C and forget about what is the C. Even if you're not understanding completely, just add C and leave it. Okay, it's like a ritual you must follow. Now, what we are realizing that this formula cannot be true if the if the power is -1. So that's why we must mention here. This formula is only true. Okay, where n is not equals to -1. Why? Because if you make the n -1, the denominator becomes 0 and it becomes undefined. So you can use for all power except the power is -1. You cannot use it. That is what you need to remember it. Okay. So that is very important part of integration. That power formula we don't apply for all power. So to understand what is the answer for this question, we can go back to old
X raised to
differentiation.
infinity.
Yeah, no, that is like undefined. So we cannot apply the formula for that value. So to understand why that formula is not applied, look at this answer. What is the d by dx of ln x?
1 upon X.
1 upon X.
Exactly. So if I integrate 1 upon x with respect to dx, it must
1
give you
ln X plus C.
correct. That's why this is not following the. So you can see that this is not following the power formula. It is following the log formula. Okay. So now this is the most powerful formula in physics. And many times we also write like this, like a dx by x equals to ln x.
Sir, but 1 upon X is X raised to -1.
हाँ तो अभी बताया ना, अभी तब से तो ये बोल रहा हूँ मैं. क्या बोला मैं? तुम सुनते नहीं हो क्या? ये क्या है ये? What is this?
Sir, it is undefined.
Exactly. If it is -1, we cannot apply the power formula. इसका मतलब ये नहीं कि we cannot apply the integration rule. Integration rule will be applied with some different function. Okay?
Yes.
So formula will change. So when it is -1, you cannot apply the power formula. That is what you need to remember. That's it. So when we have 1 by x, it turns out to be ln x plus c, and that's very interesting. That's very interesting. Now, what will happen, sir, if I write dx by x square? Can we apply the power formula now, or the log formula? Which formula we should apply? Log or
Sir,
power?
power.
Power.
Exactly. So now, if I write this, we can write this as a dx x power -2 dx, and we know the integration of this. It's pretty easy. How much is this?
So X raised to -1
X raised to -1 upon
-1. So
Right.
it will
We
be
can write
-1 yeah.
-1 upon X.
-1 by x plus c. So now these kind of equations will come more often, like x cube.
So it will be X -2 upon X root X. X square, sorry.
X square, right, plus c. So now what is the integration of dx by root x?
x raised to 3 by 2 upon 3 by 2. So sorry, one.
First, you need to write as a power, then you can apply the power formula. What you can write here?
So it will be x
You
raised
just
to
apply
1 by 2 divided by
1 by 2.
So 2 upon root x.
Why upon root x? It is 2 root x, in fact.
Oh, so sorry. Or 2
See,
upon x
when
square
you,
plus
yeah, when you add 1 to minus half, it becomes plus half. So the power, the new power is plus half, and you divide by plus half, you get 2 root x.
So no, I did calculation mistake.
Okay. So now what is the integration of dx upon x root x?
sir x raised to 5 by 2 upon 5 by 2.
Okay. So this is like x to the power minus 3 by 2 dx. So you guys are taking the power formula even in the denominator, which is wrong. You must first bring the power in the numerator and then apply the power rule. No? You guys are not getting it. So this is minus 3 by 2 plus 1 upon minus 3 by 2 plus 1. And just use the formula. So this will become minus half. This is also minus half. So this is minus 2 upon root x. This is the answer.
So
After
I got
simplifying.
minus 2 upon root x plus c.
Yeah, correct. That's right answer. Now let's do some more practice.
Sir, before starting that, can you show the log wala? I missed that.
Look at this. This is log 1.
Sir, what is that?
So if you know the differentiation, the inverse process is integration. So if the differentiation of ln x is giving you 1 by x, then if you reverse it, just a minute. Okay. So now if the differentiation of this is this value, so the integration of this will give you this one. That's it. You have to remember this.
So then c is 0.
Pardon?
C is 0.
No, this is oh my god. So every time I need to explain this. Okay, you need to understand that I haven't given all possible case of differentiation. So even this will give you 1 by x, right? This is called in general. In general. So when you integrate, you will get ln x plus some constant. You have to write this. I'm only showing the integration part. Plus c is something which I'm not showing actually. You just add it.
Sir,
Okay.
I have a doubt. Sir,
Where?
so if integration of if there is sin x, then it would be cos x plus c.
Yeah, of course. So look at this. We'll come to that. Now tell me, what is the differentiation of sin x?
Cos x plus c.
No, in differentiation we don't write c. The differentiation of sin x is cos x. That's it. Even the differentiation of sin x plus any constant is how much?
Cos x.
Okay, fine. So this is the in general way of writing. So now tell me, what will be the integration of cos x?
Or sin x plus c, which is
Sin x plus c.
Okay, that's correct. So this is sin x plus c. Now tell me, what is the differentiation of cos x?
Minus
sin x plus c.
Minus sin x. Just wait. You guys get
Sorry, sir. I thought
yeah.
I
So now
did wrong.
what will be the integration of minus sin x?
Cos x plus c.
Cos x plus.
plus c.
So what is the integration of sin x dx? If I remove the minus from both sides.
Minus cos x plus c.
So the idea is the integration of sin x gives you minus cos x, because many times the student will make commit mistake here. The differentiation of sin x is cos x, so integration of cos x will give you sin x. But if you integrate sin x, you will get minus cos x.
Sir, so if there is
Sir, it is if there is sine 2x
also same, that only sir.
or 2 sin x. Sir,
So
we'll
if
get 2
2
sin x,
sin
we'll
x
get minus cos x by
minus
2.
cos x upon 2 plus c.
But what about sine 2x? So,
Okay. So now integration of sin x is giving you minus cos x plus. That is very, very
So,
important.
so
Yes.
if it is 2 sin x, then it would be minus cos x by 2 plus c.
sir,
Okay, yeah.
I'm asking about sine 2x.
Okay, which one? Sin 2x or 2 sin
Sir,
x?
2 sin x we can find out, which is minus cos x by 2 plus c. Then what is about
So what else?
what will get out
Sine
of
2x.
sine 2x?
Minus
Okay.
cos 2x plus c. Or sir, कुछ differentiation भी है.
So now there is a problem here. The problem is like this is the new variable and this variable is not matching. Normally what we know is sin x dx integration, but here we have sin 2x and here we have
Sir, then I know, sir, can I do this
yes.
one?
Yes.
Sir, it is a function of x, which is f of x is equal to 2x, and
Yeah.
then f of gx equals to then we will get the as you did first, that g dash du by g dash x.
Yeah.
So we can do
So
like that.
see, what you can do is you can call this as u, and where u is 2x. Now u is 2x, right? You can check. Yeah, u is 2x. So now du by dx is how much?
So minus 2.
2. Just a bit. So you can see that we can write du by 2 equals to dx. Now I can substitute here. So it will become the formula which we know. Sin u du by 2. But 1 by 2 is constant, so we can take it out. And when we have sin u du. So now you can see the variable is matching here. That's nice. So we can write minus cos u plus c. That's it. But the u we assumed in the beginning as 2x, so I can resubstitute here. And then my answer is minus 2x by 2 plus. So this is what I was talking in the beginning. Hello? Hello?
Sir, it would be minus 2 cos 2x plus c, no? So because we are taking half outside and then shifting it to other side, so it would be 2 minus 2 cos 2x plus c, no?
Minus 2 cos 2x. Why?
So because we are taking half as constant and then shifting it
So
to the other side.
no, we are not shifting. We are doing the integration. We are not taking differentiation and doing integration. We are directly doing the integration. We know the formula of sin x dx. Okay, the answer is minus cos x. That's it. And half is half there. We are not shifting here and there. Are we shifting? I think you guys got too much confused here between the process of getting the formula and doing the integration. So what I was showing is that how the formula of integration has come into picture, and to understand the basic formula of integration, you need to remember the basic differentiation which I gave you in the beginning, and from there we deduce what could be the formula of integration. Okay, so what is this? Is what I have showing you guys, and you guys are taking it very differently. So just try to realize what I'm doing. You are getting confused, too much confused. Like this much confusion is not required. You can do it easily. Okay, so there are too much confusion. We'll do this.
This will give questions.
So I have one now.
Yes.
Sir, if it is 2 sin x, so we can take 2 as common. I mean constant and take outside.
No. What do you mean? If it is 2 sin x like this,
Yes.
Sir, then we can take.
yeah, we can take. Then we can take it
Sir,
out.
Sir, and one more, sir. If it is 2 sin x and after so that we du by 2, so we can take both as constant out. No?
Yeah, we can take cancel. Even we can cancel also.
So then we'll get minus cos x plus c.
No, we'll get nothing because he's saying du is dx.
So then du by
We can't do. We can't do that.
dx, right?
We have to just leave like this. For integration, it should match here. The both must match.
So du is 2tx, right?
No. For his question, he has not explained
Oh.
what is du. So if it is 2x, then it's fine. Yeah, that we can do that. Anyway, the idea was his question was to understand about the intermittent constants. Okay, just wait. See, I mean, as of now, you just add the formula. I will tell you the properties of integration later on. So, what are the properties of integration? And it is similar to the differentiation. So, you can add multiple terms. You can integrate multiple terms. You can also use the kind of okay. We have something called product rule also, which is very difficult in integration actually. So, we'll see that. So anyway, let's see some more function. Let's take some more function. So we saw x power n, the power formula. We saw log formula. We saw sine formula. We saw cos formula. Now, what is the differentiation of? See, this is I'm giving to explain you to know the formula of integration. Nothing else. What is the differentiation of e power x?
E power x.
E power x.
So what you are supposed to remember is that because this is the answer, so I can say if I integrate e power x with dx, I must get the same thing.
E power x plus c.
Plus c, correct.
Plus
Yeah, this is always true. Now this is the idea only. So from here we deduce idea, but this is not something we are doing. We are not exchanging something. No. So e power x is e power x only. So if you differentiate or you integrate, you get the e power x. That's it. So now, okay. The next is called, what is the differentiation of, this is something maybe difficult. What is the differentiation of a power x?
A power x ln
a
x.
to the power x ln x.
ln a.
ln a.
Very good. Now imagine the reverse process. So from here I can understand that if I integrate something like this,
A power x plus c.
so I must get a power x plus c. Okay, but I don't want this to be here. But I am looking for is only this formula. So I will bring this in the denominator, and my job is done. Understood?
Yeah, so because ln a is
Because see, I don't want this to be the part of formula of integration. I want only integration of this thing. So the ln a will come in the denominator, and that's my answer. So integration of a power x is a power x upon ln a. It's division. Okay, and something you can also realize, if something is multiplied in the differentiation, it will get divided in the integration. This is a very common thing which happens.
so I have a doubt. Sir,
Yeah, go ahead.
Sir, no, not what you taught till now. Sir, what is integration of sec square x raised to n?
Okay, we cannot integrate any power unless we cannot convert into the basic formula. So only those integration which can be converted into the basic formula, or which can be converted into basic formula using either substitution or any other method, can only be integrated. Just because you give any value, it is not possible to integrate. Okay, because that becomes meaningless. But okay, with
Sir,
some
but-
additional value, we can do. Yes.
Sir, means what value I gave you? Is it means it can be integrated by further
No, no, no. What
What we
value
are
you
going
gave?
to learn.
See, the n
Not
is
this value, sir. Sec square x and the only x raised to n. Sec square x raised to n.
like this.
Yes, sir.
Again, so the problem is here, this formula and this is not matching. Because we normally we know the formula of sec square x. So what we have is x per n and we have here is x. So unless these two will not match as per the known formula, we cannot integrate. So you will say, sir, let's say u equals to x per n. Okay, fine, let's take. Then you say, sir, du by dx is how much? So we will say nx n minus 1. Okay, that is also fine. But the problem is still I will have du, which is good, but I will also have nx n minus 1 in the denominator. And this I cannot eliminate. This I cannot remove. So my formula will get
We can remove, right? Because x raised to n minus 1
no,
is
no, 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 no.
x raised to 1.
No, 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 no. Look at this. What you see, your u is x per n, and this you can write as x per n minus 1 into x. So basically, n minus 1 will become u upon x. So the formula is n into u upon x. Now, what is the idea? You cannot get rid of x. It will remain in the integration. So we cannot integrate because we have two variables, x and u. It's impossible. Unless we are not able to eliminate or convert completely into other, we cannot do the integration. So in any integration, we can have only one variable. If it is either all x or all u, but we cannot have x and also u also. That's called non-integrable function. You cannot integrate such.
So will sine square x will follow the power formula?
Just wait. I mean, see, if you keep on asking like this, then we cannot proceed to the right direction. So the problem is, we will come to the same thing, but there is a sequence of learning everything, and let's follow the sequence. Okay. So now this is the first part. Okay. Now some other formula which we are missing. Okay, which formula? So we know the differentiation of d by dx of tan x is how much? It is sec square x. So the integration of sec square x dx will be how much?
X plus c.
Tan x plus c.
Okay, so now just remember this basic formula. Okay? You need to remember the formulas. Then d by dx of let's say sec x. How much is the answer?
So sec x into sec x. No, sec x into tan x.
Correct. So if I integrate sec of x into tan of x with dx, I must take
Sec x plus c.
that's it. And then we have d by dx of cot x, and answer is minus cos x.
Minus cos x square.
So integration of cos x square x dx will give you
Minus cot x plus c.
plus. And the d by dx of cosec x is minus cot of cosec into cot. So integration of cosec x into cot x into dx.
Minus cosec x is equal to
Minus cosec
plus c.
x.
Very good. So now I think we are done with all formula. What is anything left? Done. So I think these are the basic.
So log x or d log x.
Log x.
In which differentiation you get log x?
So log x.
No. What you differentiate to get log x?
No, differentiation of log x, which is 1 by x and a 10.
So we have done this. We have done this. We have done this.
Of ln x.
You guys don't see anything. That's the problem.
Sir, it is ln x, right? But we are asking about log x.
That's a log x base 10, other base.
Yes, sir.
No. So if we have, let's say, d by dx of any base, let's say log maybe some a and x, take some base. So we need to convert this into like this. We have to use the change of base, what you can say, log a, log x, and you can put e here like this. So now this becomes like constant, and you can take it out. What you get is log EA and d by dx of ln x. So at the end of the day, it's this value. So this will become log EA upon x, which you can further write as 1 upon x ln x. That's very difficult to understand. This is a concept. X ln
The
a.
X ln A, yeah. So,
Yes, sir.
So
Excellent. A.
log of e by a we can write as 1 upon log of
yeah, sir.
e
Log
by
E
a.
by, yeah, sir.
Then a, and because of this reason, the formula will become take a new format. But this is not the basic. Like this is something you can derive, okay, from the formula which you know. So now you can say that integration of 1 upon x ln a dx, because this is the differentiation of this, right? So dx by x ln a is a log of xa, but that is bad way of writing, because at
ln
the
X
end of
by
the day,
ln A.
yeah, it's as good as writing 1 by ln a into ln x, and that's good to
Plus
write as,
C.
yeah, log of ax plus c. So why we write like this? This is not a basic formula. This is something which you can derive in differentiation or integration, but not required here as a basic formula. So we cannot put this into the category of basic formula. Now, the rules of the properties of integration. Properties of integration. What are the properties of integration? So if I have some function, like you all guys were asking, if it is a into fx dx, then a is a constant, I can take it out and I can just write a fx dx, just like this. Okay. So any constant which is multiplied to the function, not inside, not here, outside, we can take it out. First thing. Second, if we have multiple functions, let's say a1 f1x plus a2 f2x, maybe plus minus, and dot, 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 dot. There are many functions which I have written like this, and I want to integrate. So the rule says that you can break every function separately and integrate. So you can write a1 f1x dx, the first part, integrate, put plus minus as such, the way it is written, then repeat the same process for other values, and you can continue doing it like this. And now because a1, a2 are constants, so you can further write as a1 f1x dx plus minus a2 like this. So this is the addition or subtraction property. Okay, and this is what you can do. Now here the multiplication is not possible, or the division is not possible. So we don't multiply or divide in integration. So for that we have something different property that's called the integration by parts. That's very, very difficult. Oh my God. Integration by.
The previous page.
Now what is the integration by part? It says that if we have two functions, u and v, both are function of x. You may think of u is fx and v is gx. Let's say we have u and v are two functions, and now you want to integrate the product of function. Okay, so now here's something we have to apply. Okay, this is difficult. So what we write is, okay, I'm just writing. First I'll write, then I'll tell you. It's really bad formula, but this is the formula. Can you see that?
So it will be very lengthy process.
Yeah, so of course this kind of question will come when it is very lengthy. So you're not supposed to solve with it. I mean, you will not face question like this in physics hardly once or twice in entire physics course. Okay, just once or twice. But don't worry. At the end, if you do it for the mathematics, it's very common question. In maths, you will practice so much that it will become very easy. Now I will tell you how to remember this thing. Okay. So we have a way to choose. Let's say, sir, what is u, what is v? How I can choose which one is u, which one is v? Because it's not about what is written first is called u. It's not about what is written other is called v. U and v is concept in integration. So we use the concept called ilet. Now ilet is what? The I refers to called inverse function. L is called the logarithmic function.
Algebraic function.
A is called the algebraic function. E is called the trigonometric.
Sir, E for exponential function.
Correct. E is for exponential. So imagine if two functions are given to you, and one is, let's say, inverse, other is, let's say, logarithmic. So what comes first is what comes first in the ilet becomes u, and what comes second becomes v. Okay, that's the idea. But even that idea is not required. If you learn mathematics, you will realize that what we can do easily. Okay, so like I want to differentiate u and I want to integrate v. So I will choose v which can be integrated easily, okay, and I will choose u which can be differentiated easily. That's the idea actually. So what we are doing is we are taking u outside, we are integrating the v minus. Now after minus we have a big integration, which means we have to do certain things within the integration. Then what we do is we repeat the process, we differentiate the first function, integrate the second function, and we multiply the two results, and then we integrate again. Okay. So if I write it into words, u into integration of second, integration of v minus differentiation of u into integration of v, the whole integration. Okay. So what we can see that it's u into integration of v, but again we have differentiation of u into integration of v, then whole dx, and then this you can only understand through practice. There is no other way of remembering this entire process. I will solve some questions based on this also. Now, but apart from this, what is most important in integration, which every student find difficult?
Sir, please will you go back to.
So,
Mhm.
sir, like in the power formula,
Mhm.
sir, can we use that power formula in trigonometric functions like
Yeah,
sine,
yeah.
like sine square x?
We can to use any formula, we have to fit in the format, and that is where the substitution will come into rescue. Like we will learn the substitution for that purpose only. Okay, so we'll see that in substitution only. So first, let's do some basic questions, and
What
then
will
we'll
be the integration of sine square x?
Can you
integration
show
of.
the previous?
See, we
Sine
cannot
square
directly
x.
integrate sin square x, but there is a way to do it. The way is you can convert it to a linear power of x. How? So we know that there are many ways to do it. Okay, there are many ways, actually many ways to do it. So what you can write? You can write as 1 minus cos 2x
So by
upon.
one.
So if it comes to the square function, we have to convert into cos function, because we know that the power of the square becomes linear function. Okay. See, what is the idea? Idea is simple. We need to convert everything into formula which we know as a basic formula. And if we can do it, we can integrate it. So for these are two very special one, and I will actually mention both integration. So cos square x dx is only possible to integrate like this: 1 plus cos 2x by 2.
+9174091574.
Sir, and by power formula, how can we do it?
Okay. So now the sine square and cos square is very, very important formula. We have to write into 1 plus cos 2x by 2 or 1 minus cos 2x by 2, depending on whether it is sine x or cos x. Okay. Now, once you write like this, what we can do next? So let me write both integration one by one. Sine square x we cannot integrate, but what we can do is we can write as 1 minus cos 2x by 2 dx, and then we can write 1 by 2. We can break it like 1 by 2 into 1 by 2 cos 2x, and now we have two terms. So I can write 1 by 2 dx minus 1 by 2 cos 2x dx, and then again 1 by 2 is constant, so we can take it out. So we have dx minus 1 by 2 cos 2x dx. Now so far so good. Okay, and then I can get 1 by, or you can say x by 2, because the integration of dx is x, so x by 2 minus half. Now this part of integration we don't know, because the formula which we know is only for cos x dx, but here we have cos 2x dx. So here the formula we don't know. So we'll do something to get the answer. That's not difficult. So we can do something to get the answer. So similarly, you can proceed for the same thing. If you proceed for the same thing, I can write directly in one line. So you'll get x by 2.
X by 2 minus 1 by 2.
No, plus.
Sorry, plus 1 by 2 integration.
And then this integration I have to do. So now what we can do to get this integration? That's not difficult. So here comes the rescue of the substitution. Okay, so what I'll do is to make it a generalized formula, I'll make it like this. So if I make it ax and dx, then I want to make a general formula of cos ax dx. How we can find the answer of cos ax dx. Okay. And for that matter, I can in fact create a formula called how to find the, let's say fx is this is the integration which you know, and after integration you're getting something like this, a new function. So let you know this. So imagine you know this answer. The first answer you know. The question is how to get the other answer. Which answer? What if I replace ax by ax? And now I'm looking for the answer. So in one short, I can say the answer is f of ax by a plus c. This is what you can apply directly in any question. So if you know this answer, and if the x is multiplied by some variable, you just divide by the variable, you get the answer. Okay. In fact, if you replace x by some linear combination like ax plus b, the answer will be f ax plus b upon a plus c. That's a very, very important formula in integration. And now I will derive this, why this formula works, okay, how it works. So now the answer is simple. Now this answer you can add directly. You know what you can add? What is the integration of cos x? Remember? Integration of cos x is sin x.
Sin x.
So you can add as sin 2x upon 2. See?
Yes, sir.
Just divide by the number which is coefficient of x. Just divide by that number, you will get the answer. And similarly, you can add here x by 2 minus sin 2x upon 1 by 2 is there. So this will become answer x by 2 minus sin 2x by 4. And same thing you can do here. X by 2 plus sin 2x by 4. Now, question is why this formula works, sir? The answer is simple. Look at this. Let's say if I give you f of ax plus b dx. Now you can see clearly that this is not matching. But don't worry. Take u equals to ax plus b. And if I differentiate du by dx, what I'll get?
A.
Exactly. So I can replace dx by du by a. Right? Can I write like this? Come on, guys. Please tell me.
Yes, sir.
So my formula will become f of u, because I have taken this as u,
Du by dA.
and du by a. And so I can take
sorry.
a outside. This formula is as good as fu du. No, because I know this answer, so I need to just divide by the a to get rid of the entire thing. So that's the idea why this works. This is called method of substitution. Method of substitution.
Yeah, so we derived it for cos 2x. No?
Yeah, so you can do it for any question in general, and it is equally valid for. Let's say I'll give you this example. Let's say if I ask you, what is the integration of this? What is 1 by x dx integration? You know the
Not
answer.
possible.
No, this is why it is not possible. The power
Because
formula.
x is to minus 1.
The power formula is not valid, na?
Oh, sorry, ln x.
ln x. Now, what I do if I make a small change, if I write it as 2x minus 1. See, I haven't changed the power of x. X is still x only. But I have multiplied by 2 and I have subtracted 1. So it's called linear combination. This is called linear combination. This is called ax plus this is called the linear function. So as long as x is the linear function, you can write this as 2x minus 1 divided by what we need to divide with. That's it. So if I write dx by 1 minus x, what should be the answer?
ln
ln
minus
1 minus x by 1.
By minus 1. The coefficient of
So
x.
why 2 and minus 1?
So
Why?
coefficient of x.
This is x.
So why in the denominator 2 and minus 1 is there?
No, this is the question. This is dx upon 2x minus 1.
No, sir, I'm asking about RHS. So,
RHS. Where is RHS? This is RHS. This is okay.
So,
So when you change this to new value, the ln will also change from this value to this value. This must remain same, no? So when it is x, when it is this value, you have to write this value.
Sir, I have just one question.
and why, sir, we divided it by 2?
Because this is the format, no? Ax plus b. So we have to divide by coefficient.
So we know that value of that number.
Okay, listen. See, I mean, if you're getting so much confused, then every time when you get so much confused, then there is a way to solve the question. You start with method of substitution on your own. So what you can do is you can just say let u is 2x minus 1. Or you will say why we are assuming u? Because that's a linear function. And we know that if I choose u as this value, I will get a format of something upon u. So let's see something, I mean, how it becomes. So if you differentiate this, what you get? 2. So I can write dx equals to du by 2. So now formula, my function becomes du by 2 u. And I can take 1 by 2 outside. So we have du by u. Now can you tell me what is the formula of du by u? What is the answer for this?
ln u.
ln u plus, that's the correct answer. And what was u in the beginning? What you assumed as u?
2x,
2x minus 1.
So is the answer.
Yes. So can
Now,
you give
this entire thing, either you do this entire thing or you remember the formula which I gave you. This formula. So formula is what? Sorry, this is the formula. You have to remember this formula. If you know the answer for one, the answer for the other will be just having some modification. And in case of linear, okay, this is okay. Okay, anyway. So now imagine if I give you the question like this: what is the integration of e to the power kx dx?
The k is constant.
Yeah, k is constant. So
sir k to the power x plus c by k.
once again,
e to the power x plus c.
E power x plus c. No. The answer is e power kx by k plus c.
Sir, I told first that.
Sir, I have got the e raised to the power kx divided
By
by
k
k. I didn't
plus
got because sir, for that we have to take k outside, but k is at the power. So how can I?
So k is the power. You can't take k outside because k is the power of e. You can it's not multiplied here. So okay, if you are not getting the answer why this is the right answer, so you can say let u equals to kx. Then du by dx will be how much? K.
One.
K.
k.
Right? If you are not getting this part, then there is a problem. So I can d equals to k dx. So I can dx equals to how much?
du by k.
So now replace e power u du by k, and 1 by k is outside. We have u du, and now this is matching perfectly with the
Yeah,
formula which
sir.
we know.
Now understood.
And because u in the beginning I assumed as kx, so I'll resubstitute to go back to the original formula. That's my answer.
So
Okay.
please you give one more question like this.
Yes. So if I give you integration like e power minus lambda t dt, where lambda is constant. So what will be the answer for this integration? Can you guys tell me this answer?
Yes, sir. It is.
So minus 1 upon
Hmm.
so minus 1 upon lambda e raised to lambda t plus c.
That's the right answer. Very good. Okay, that's perfect answer. Now, if I ask you what is the integration of sine omega t dt, where omega is constant? What is the integration of sine omega t dt?
Cos t by omega plus c.
What is the integration of sine x?
So
Cos
wait, sir. Solving something. Sir.
Go back and check what is the integration of sine x. I think there is a mistake.
Sir, it is minus cos omega t
Ah,
divided
minus.
by omega
Yes, sir.
Once
Minus
again,
cos.
minus
cos
cos.
omega t divided by omega plus c.
Very good. That's the right answer. That's the right answer. So what is the integration of, if I ask you, cos kx plus cos kx dx?
Sir, it is sine kx by k plus c.
Very good. So what is the integration of sec square 5x dx?
So is it 5?
So before you write the answer, you think of what is the formula of sec square x?
Is it 5?
And 5.
Pardon? Tan?
So tan 5x upon 5 plus.
So
Correct.
it is tan 5x by 5 plus c.
That's correct answer. Very good. So now I hope you are getting this now slowly. You guys are getting the hang of this concept. So let's say if I give you what is the integration of minus maybe 2x plus that's not required, but anyway, plus 5 dx. All right. So what is the answer of this? So all left. Okay, they got disconnected, I think.
So can you show that formula? I didn't note it.
Okay, so what is the integration of e power x?
Sorry, power x.
So you have to think that way only. Like if it is the same e power x, then from there you can derive it.
So can you show the last page? So no means previous.
Okay.
So one more page before. So done. So and one more page can you show before one last? So done.
Okay.
Sir, differentiation is used in which topic of physics?
In every chapter of physics, the physics is all about differentiation and integration. So mathematically, we do lot of differentiation and we do lot of integration, and that is the requirement in physics from the very first chapter till the last chapter. So you will never get rid of it. It is always going to be there, always.
So what is answer of this one?
So this is of course e power minus 2x plus 5 upon minus
5
1.
upon minus 2.
Right.
Plus
Correct. Okay, so 5 doesn't matter. What you multiply, what you add doesn't matter. What matters is only the coefficient of x. And anyway, if you substitute and if you want to do it in more rigorous way, you know that how to do it. So you can take this as u, right?
u.
And you want to differentiate this.
Minus
So
2.
I'm writing directly. I'm writing in 2 steps in one line, and then my formula become e power u, and dx becomes dx is actually du by minus 2. So it's minus 1 by 2, and it's e power u. That's the answer. But what is u? What is u? I assume was
Sir, plus C.
that I'll add in the end. Okay, I always add c at the end. So in the middle of calculation, no need to write. When you write the final answer, then just write c, and then leave it. If you don't write c, it will be taken as the wrong answer in examination. If you're writing an examination in which you are supposed to solve it on paper, and if you miss the c, it is assumed to be wrong answer. Okay, so let's do something more about it. So now we'll do some question in which it is not obvious that we can solve, but it will be yeah, kind of easy to solve. So let's see how which kind of question we can solve. So I will give you xp minus x squared dx. Now this looks we can't solve, but we can solve actually. And how to understand we can solve? You can see that this is x square and this is x. So if we differentiate this, the power, you can actually get x. That's the hint kind of thing that you can imagine.
I didn't understand what you just said.
Okay, don't worry. So let's say we want to integrate this function. I am giving you a new function called x e power minus x square dx. Now, we have been taught so far that integration of e power x is e power x, right? We know only this much, but we haven't thought about something like this. It's really weird, right? So how to integrate this part? So what you will start with? To make it look normal, I will take as u. So this is how I begin, because now I can feel it. Okay, it's fine. What is u here?
Sir, it will be du by dx.
Yeah.
Sorry, du by x.
So what is u here? Minus x square. So du by dx is how much?
Minus x. 2x, sorry.
So basically, I can write it, if you look carefully, I can write this as 2 times x dx. And see, we have x dx. This is like e power u. But even though you are not able to see that, you can write dx equals to how much? Du by minus 2x. You can write like this. And now substitute here. Where instead of dx. If you substitute, what you get? X multiplied by du by minus 2x, and this will cancel out. So that's look like now normal thing. It's a e power u du, and I think we are very much comfortable with this integration. So what is the answer for this?
e to the power
X to the power minus x square divided
Correct. So the answer is
by
minus.
2.
This is the answer.
Sir,
Now,
this one can you explain once again?
yeah, definitely I can explain once again, and this requires once again explanation. Now the rule is this is something called method of again substitution, and what you need to realize is that when you have a function which looks very weird, then you have to choose u, the u which I am choosing all the time, in such a way that it becomes something meaningful. Okay, the meaningful in terms of solving. Okay. And if it is meaningful, then we can actually solve by differentiating the u and then replacing the dx in terms of u, because I want my integrator to be u, because I have taken u as my variable. So I also want my integrator as u. So I will remove the old integrator, which was dx, in terms of new integrator, which is du. And once you get that new integrator into place, you can see that it automatically becomes integrable. It means you can integrate this. So let's take some more example, then that will be more clear. For example, someone was asking me,
so can you show the previous page? Sir, done.
okay. Now look at this. This is question. This is very important. Imagine if I give you a question like this. Someone asked me, "Sir, can we integrate this?" So let's say I'm giving you sine x power n dx. Now this cannot be integrated, but if I write here cos x, then this can be definitely integrated. Now how? Can you try guys this as like what we can do to get this answer? What should be my u which can let me solve this question?
So,
Yes.
nothing, sir.
N is constant. N is constant.
So cos x can be u.
If you choose cos x as u, but it will not help because you cannot get rid of sin x power n.
So
See,
we will take whole sin x raised to the power n as u.
no,
Yes.
even that there is a problem. If you take the whole as n, then again you cannot eliminate this. You cannot integrate this. That's a problem. You have to choose or think carefully that
So,
what
but we can cancel out cos x, right?
no, you will not be able to, because if you take the entire thing as u, and if you differentiate it, it will remain as a power of n. So it's difficult to get rid of. You can try this, you can try here, and you will come to know that what I'm saying. So the best choice is take sin x as u. That's it. Now, once you do this, your job is simplified. How? Because u is sin x, so du is how much? Du by dx is cos x. So you can see the dx you can replace by du by cos x, right?
Yes.
So I can add cos x, which I am not affecting, not changing, and then I have u power n, and then I have du by cos x.
Cos x will get cancelled.
And then I have the power formula, because this is a very famous power formula. What I can write? U power n plus 1 by.
N plus 1.
So my answer is sine of x power n plus 1 upon n plus 1 plus c.
Yes.
Now the struggle for every beginner, the struggle is thinking of the right u. What should be my perfect u, which can make it simple? And if we are not able to find that u, it's always painful. So let's take this question. So maybe I can write as x dx upon under root of x square plus 3. The question is, can we integrate this?
Yes, so we can.
Try this. Okay, I'll make it better. So this is a very famous question of physics, where R is constant. So you can think R is constant. So don't worry about R. Now integrate this. See, I will tell you something as a hint. We
No,
always
sir,
look.
we'll solve, sir, please.
Okay, okay, fine.
Sir, I got my answer as u raised to 1 by 2, which is root u. Sorry, I took u as x. So it is, sir, under root x square plus r square plus u.
That's the right answer. So that is the right answer. Very good. Well job done. So this answer is x square plus r square under root plus c. Now this is a very famous expression in physics which we come across, and it's very common. Very common. So I hope if you all of you have not got the answer, if what we choose u, what is the perfect way of choosing u?
X square plus r square.
Correct. And if I differentiate, I'll get 2x dx. 2x basically. So normally I do it in one line, which you will also understand why I do in one line. So you can add like this directly. And so you can see that x dx we can replace by du by 2. So this is a simple integration. Now this turns out to be only this much, right? And this two we know this is 1 by 2. I think 2 is missing, or what? No, 2 will not miss. So maybe, yeah. So what is the integration of 1 by du by root 2? This is 2 root u. Cancel. So what we get is root u. And so the answer is correct. It's x square plus. It's correct answer. So let's do something more. If we can go to next page, if you all have copied.
Yes, sir.
Sir, I took x square plus r square under root as u, and I got the same answer.
You took x square plus
R square under root as u, and I got the same answer.
You will get the same answer. That's perfectly okay. But okay, if you can choose, in fact, like this, that's even better. Because if you differentiate, if you know the chain rule of differentiation, this will become 2u du by dx is 2x. So what you can see is that u du is x dx. So my answer will become x dx upon under root of x square plus r square. I can rewrite as u du upon under root of u square, which is u du upon u, which is just du, which is just u, and which is just under root of. You can do like this also. In fact, I will prefer this method, what you did. So whenever we have a root, you take the under root of everything as square value. Not I'm saying you take you take that as square value. And that will help you in solving the question very fast, effectively. Okay. So, let me create some space for next column. So let's do some new problem. Okay. So I hope you will like this problem. Okay. The question is cos x dx upon root sin x. Okay, guys, you can do this. It's not difficult. Do you want to try this question? Hello guys, 1 2 3 1 2 3. Anyone there?
Yes.
So you want to try this question?
So sin x will be minus cos x.
Hmm.
Sir, answer is 2 into under root sin x plus c.
Yeah. The answer is under root of 2 root sin x plus c.
Sir, before what you did was u square is equal to x square plus r square. Sir, I also did the same thing. I took u square equals to sin x and then solve it.
Okay. So you guys got the answer? Everyone?
Yes, sir.
So what do you assume? You can assume either u as sin x, or you can assume u square as sin x. It's up to you. So, okay, going by the old convention, you can say u is sin x, then du will be sin x, cos x dx. I can add directly because I know this will be after rearrangement. I can get this answer. So I know that this is actually du by root u. That's it, and this answer is 2. This is a very famous answer. So we can add this as sin x. Yes. Okay. Done. So the idea is the substitution is the way to success in integration. So the one who can create the substitution in an easier way can solve the question even easier. Okay, so the entire idea is about substitution. Okay, so now we'll integrate inverse function, and the way
So
to
can you
integrate
solve this one?
which this one.
Yes.
Take u as sin x, differentiate both side by x, write dx as du by cos x, but this is how you will understand better. Substitute in the actual formula. So I will write cos x and dx as du by cos x upon root u. This will cancel out. I'll get du by root u. I will use the power formula because it's minus half du. So I will write u minus half plus 1 upon minus half plus 1 plus.
Sir, I got it.
This will become 2 root u plus. But u I have taken as sin x. I will resubstitute, and here is my answer.
Sir, I got it now. Sir, I
Okay.
get one.
Okay.
For that.
No problem. Don't worry. So now let's do some easier question. Like this is again you guys will find easy. So let's say if I write maybe what I can write. What I can write. Okay, sine qx cos 4x dx. Let's say we have something like this, sine qx cos 4x dx, and I want to integrate this. So what is the right way or right thing to substitute? That's very interesting. Should we substitute cos or sine?
Fine,
Cos.
sir.
Yeah, so there is simple rule for it. Substitute the odd power. That's simple idea. Always substitute the odd power. If we have uh, different power is even and odd. So sine is odd and cos is even. So I will go for the odd power. So what I'll do is I'll substitute u equals to sine x. Now you may ask why, sir, why you did this? Okay, you will realize. Just wait for something. You will realize. So anyway, if I do this, my formula will turn out to be u cube. Okay, and I think I made a mistake. Substitute the even power, not odd. Even will work.
Yeah, sir, of course.
You have to substitute cos x. Now, if you do this, you will get sine cube x and u power 4 dx. Now, I have to convert the integrator into u. So, to do so, what I can do is simple. I will differentiate this. So, if you differentiate, what you get is cos x dx. And because this is cos x dx, so I can replace dx by. So dx I can write as du by cos x. What I did minus sin x. Sorry, my bad. So now what we can get is minus sin x, and now that's very interesting. What we are left with is minus sine square x u power 4. Now what we wanted is even function at the final. So why? Because we can convert sine square x as 1 minus. And we know that cos x we have taken as u. This becomes 1 minus u square du. Now this is interesting. Now it's become u power 4 minus u power 6 du. And then you can get the way you know. You can do the integration separately. And no, now it become u power 5 by 5 minus u power 7 by 7 plus c. And this will be, it's put at minus 5. I've taken the minus sign inside. And what was u? U was cos ex. So I can write as cos 7x upon 7 minus cos 5x. Okay, so now this is there is a generalized formula for this. You can remember this formula. So if I give you sine mx into cos nx dx, we look for the even and odd power. Okay, so if we have, if we both are even, what will happen? If both are even, then you can convert one into other, and then it's a long process. Then if it is both even, then it's a really long process to solve. So if both are even, they will keep it a small power. If both are, if one is even, another is odd, we can solve for any power. So let, if m is even, n is odd. Okay, so whatever is even, if you differentiate, you will get one of the odd, and okay, that's simple. So you can take, if m is even, take u as sin x. If n is even, take, and m is odd, take u equals to cos x. If both even, okay, then there is a different way to solve this. If both even, we don't take a u and v. What we do is something different. So that's called manipulation. Okay, I'll show you something. So imagine if someone is asking, so what is the integration of maybe cos square x sin square x? Okay, so what I'll do is I have to keep on moving forward and I have to convert into a simpler power. So first I will mix, because it's sine and cos and the power is same. So I can write as sin x cos x whole square, okay, into dx. And this we can write further as sine 2x, because you know the formula of sine 2x, right? So 2 sin x cos x is the formula of sine 2x. So if I divide it by 2, I'll get sin x cos x. And then this will become 1 by 4, and this will become sin square 2x dx. But for this further, we have to write as, because it's a square, I can convert it into linear power. I can write as 1 plus 1 minus cos 4x by 2 dx. Okay, now this is simple to integrate. So what it requires is you have to convert into eventually linear power of cos, and that is only rescue. There is a way to solve this question. It becomes 1 by 8 integration of 1 minus cos 4 times x dx, and this you can again break it into 1 dx minus cos 4x dx, and this becomes 1 by 4, and 1 dx to we know is answer x, and cos 4x becomes sin 4x divided by 4, then plus. Okay, so it's a really lengthy problem, and that is what you have to learn. So oh, like this. So when we have even power, we have to convert eventually to linear power of cos, and that's a rigorous process. They will not give you a very high power. They will give you some power which you can manipulate after 2-3 steps. So integration is all about knowing the trigonometric skills. Like if you are really good with trigonometry and its skills, you will find the integration very, very easy. I will not complete the integration here only. So I will take one more lecture and we'll go even more deeper into the process of integration. We'll solve some more challenging problems and how to solve other varieties of problems. Okay.
So what did you do in the third step?
Sir, yeah, sir, I am also.
Which
So
third
1
step?
minus cos 4x upon
Yes,
2.
that
1 minus cos 4x. Okay, how I write that thing?
yes.
Can you mark with some your mouse? Okay, which part you are talking about? Just mark.
So 1 by 4.
Okay,
Yeah,
okay.
this part.
Okay. So now this is something interesting. This is easy also. It is a part of trigonometry where you might have learned about cos 2x formula, which is cos square x minus sin square x. Have you studied this formula? Yes or no?
Yes, sir.
Okay, fine. So this we can write as either 2 cos square x minus 1, or you can write as 1 minus
Sine,
2
2
sin
sine square x.
yes, correct. So now if you rearrange, you will realize that you can always write cos square x equals to 1 plus cos 2x by 2, and you can always write sin square x as 1 minus cos 2x by 2. So now if I change from cos square 2x, it becomes cos 4x by 2. Like it becomes double angle. Angle becomes twice, right? If it is sin square 2x, it becomes 1 minus cos twice of this angle. Just a formula, just a formula. I'm not doing anything extraordinary. So the formula, the angle is becoming double. If you convert the square to linear power, the angle becomes double. So if I make the same thing for sin square 2x, so it becomes cos 4x. Do you guys realize this? Yes or no?
Yeah, sir. Yeah.
So
So,
this is, yeah.
Sir, in that step, we can directly take sine square 2x, sine 2x the whole square as u, and then by substitution method, then we can solve.
No, no, you won't be able to solve, because see, when you take something as u, then its differentiation should be present somewhere else. That's the idea. Like in every other question that you have solved so far, whenever you took u and you differentiated, you saw that something else is present.
Or
Hello guys. Okay. If this part is clear or not, tell me.
Yes, sir.
Basically, it's a trigonometric manipulation, and I will tell you. The
so what
entire
we will do
integration.
after the second step?
Can you mark which step you're talking? Okay, okay. Okay, so do you remember the trigonometric formula? Yeah, that I am. So do you remember the first formula, the formula which I written above? Okay, this one. Because that is the root of all other formulas. Okay, even if you don't remember that, I'll tell you something even more interesting. What is more interesting is okay.
So it is derived from cos A cos B minus sin C.
It's like if you know the cos A plus B formula, which is cos A
Cos
cos
B
B
minus sin A
minus sin. If you know from here, then I can, if I make it A and A, both are A, it becomes cos square A because A and B are same, minus sin square A. And we know that how to convert cos square into sin square and vice versa. So I can write 1 minus sin square A minus sin square A, and it becomes 1 minus 2 sin square A. This is cos 2A. So imagine if you start with cos 4A. So I can write 2A plus 2. So the one formula should be what? Cos A. Okay, cos A cos B minus sin A sin B. This is cos square 2A minus sin square 2A. So I can write 1 minus 2 sin square 2A. This is cos 4A. So sin square 2A is 1 minus cos 4A by 2. And now write x instead of A. So sin square 2x will be how much? Does it make some sense to you guys now?
Yes.
Okay. So in case if it is not making sense, go back to trigonometry, practice those formulas, and I will tell you something very interesting, very important also. Integration is all about application of trig only. So if you are someone who is not good with trigonometry, the struggle will be more here. So it's good to go back and revise.
Sir, which formulas are you talking about?
All formulas.
Yeah, sir.
Every
Sir has taught us.
Yeah, so just go and practice it. See, in fact, even sir has given you the formula. I will suggest that you derive on your own till you feel it. Like you have to feel those formulas, that how it has come, why it has come. Don't mug up. Just write equation and derive. Just write equation, derive. Okay. Okay, guys. So I'll end the lecture here, and we'll learn more of integration next class. And then every magic formula. Let's say if you remember the first class, we had areas and volume, and I left the integration part. But what I said is, okay, we'll do the rest part after the integration is done. So now you can go back to those formulas, and actually if you integrate those formulas, you will see all the formulas of area and volume which you know. So meanwhile, I'm not doing it. If you want to try, if you're curious enough, you can go back and try those things. Anyway, we'll cover this the same thing in the next lecture. Okay, so we'll discuss all these things in detail. So by next lecture, I will finish your entire what we say integration. Okay.
So then,
And
in exam, when sir said us that from 11 July exam will begin. So sir, what will get
uh,
in?
no, only up to integration. The 11th July exam will have only integration. So we keep all examination 1 week before lecture. Like whatever I have taught you 1 week before, only that part will be covered, not at the present time. So up to integration will come in the examination. Or maybe it may have some sub parts. So sir will let you know. Let you know. I will discuss with sir, and then he will let you know that what will happen exactly. Okay.
And sir, whatever you have taught in mathematics, so it will come in physics, right?
Yes. Whatever I have taught is only meant for physics. So I will not say that I have taught you mathematics, because in maths you will also learn much more than what I have taught. Okay. So in physics, we need certain things, but at the problem is, let me tell you what happens. Your mathematical ability needs some help in the beginning, because in maths, the integration is the last chapter of the 12th. So almost 1.5 years from now, you are going to learn integration. And differentiation also you learn after 1 year from now. So we cannot wait for 1 year, right? So we cannot wait for 1 year when you will actually learn these things in 12th. That's why in physics it is taught as a mathematical tools which develops the idea that how integration is evolved, how differentiation is evolved, what is the geometrical meaning of all these things. So physics is all about visualization. So I have tried to give you visualization techniques, like how you can visualize things, how you can imagine things, how you can make these things physical, okay, instead of making it virtual. Okay, understood? Okay, guys. Okay, I have another lecture. Goodbye, take care. And if you have any doubts, you can ask in tutorial with Amit sir.
So
Okay?
can you send this PDF?
Yes, yes, definitely. Just I'm sending it.
Hello, sir. Sir,
Yes, yes. Tell me.
sir, we have to leave the meeting now.
Yeah, yeah. You can.
Okay, sir. Thank you, sir. Bye, sir.